So we're moving on to chapter 7 now, which is applications of forces. This chapter is basically a summary of pretty much everything else you've done already so far. So it uses forces, it uses friction, it uses pulleys, equilibrium, Newton's laws. It's a really big summary of everything, just applied to a range of different circumstances. Now, if you haven't already, you should be following this with the applications of forces PowerPoint, because although I will be going through the examples as they are in the book, however, what I'm not doing is necessarily doing it in the way that the book would do it all the time. They sometimes show you alternative methods, and I don't necessarily think that they are the best methods or necessarily the easiest to follow. So, example 1. The diagram shows a particle in equilibrium under the forces shown. So we'll draw that here for you. So we've got a particle, and you have force P acting in this direction, which is at 30 degrees to the horizontal, and then a force of 4 newtons in that direction acting at 45 degrees to the horizontal. We also have a force acting vertically downwards worth Q newtons. So the question says, by resolving horizontally and vertically, find the magnitudes of the forces P and Q. Now, actually in the exam, you wouldn't be told explicitly to resolve horizontally and vertically, you would just be told to find the magnitudes of the forces P and Q. And you'd have to know to resolve forces. So I'm just going to draw on my vertical and my horizontal forces for my two forces that are acting at an angle, so that I've got them all there. Now I'm going to resolve my horizontal forces first, and I'm going to do this because then I completely eliminate Q. I only have one unknown, which means I can actually solve for P. So resolve horizontally. So P cos of 30 must be equal to 4 cos of 45. So remember, I know they're equal because this is in equilibrium, it is static, which means if I did the force going forward, subtract the force going backwards, or right and left, this would give me 0. So I know that therefore they must be equal to each other. So obviously, now I've just got an easy rearrangement. I know to divide both sides by cos 30. So therefore, P is equal to 4 root 6 over 3. I'm writing down my exact answer because I'm definitely going to need to use my answer for P in my working out for Q. So obviously, if I have an exact answer, it's going to be more accurate when I work out Q. So now I'm going to resolve vertically. So I've got my two vertical forces acting upwards. So I've got 4 sine 45 plus P sine 30, just writing P because it's easier than writing that down. And that is equal to Q. So I'm just going to substitute all of this in, obviously substituting in my known value for P. So therefore Q is equal to 4.46 newtons to 3 significant figures. Perfect. So now we're going to move on to example number 2. So the diagram shows a particle in equilibrium on an inclined plane under the forces shown. So I'm going to draw that out there. Now in the example, it has sort of a dotted or dashed line with an arrow indicating X. It's just telling you this force of 8 newtons acting in that direction is parallel to the plane. So rather than writing a dashed line, I'm just going to draw a straight line because it's easier. So I'm going to draw my horizontal in, and that force of 8 newtons meets the horizontal at 30 degrees. Then got a force acting in this direction of 2 newtons. Again, the dashed line with the y is just telling you that it's acting perpendicular to the plane, so I don't really need to draw that in. I then have force with p newtons acting at an angle of alpha. And then I have the weight of my particle, 5 newtons, acting vertically downwards. So the question says, find the magnitude of the force P and the size of angle alpha. So this time I'm drawing in, rather than horizontal and vertical, I'm drawing in all my forces that are perpendicular and parallel to the plane. So draw these forces in first. I know that's 30 degrees because my angle's in parallel lines. Okay, so I'm going to resolve parallel to the plane first. In this example, it actually doesn't matter which one you do first because P is the only unknown here that is a force, and alpha is the only unknown that's an angle, but they're both within the same part. So no matter what I do first when I'm resolving parallel or perpendicular, I'm going to have both P and alpha. So it doesn't matter which I do first, I just chose parallel. Again, it's static, it's in equilibrium, so therefore the forces going in one direction are equal to all the forces going in the other direction. So parallel, P cos alpha is going to be equal to that force of 8 newtons acting down the plane plus 5 sine 30. Now luckily sine 30 is a really nice one, so just type all this into my calculator. P cos alpha is 21 over 2. Can't do anything with that information right now, so I'm just going to resolve my perpendicular to the plane. So all the ones going away from the plane upwards first. So I've got 2 plus P sine alpha is equal to 5 cos 30. So rearrange. P sine alpha must be equal to, so type it into my calculator. I'm going to write my exact answer if I can. So -4 plus 5 root 3 over 2, which is approximately equal to 2.33. But that doesn't really matter, just so that you've got an idea if you do press the SD button. Now, when I have something in terms of sine and something in terms of cosine, that's really useful because I know that if I divide sine by cosine, that I get tan. And obviously P divided by P means that P cancels, so I've only got one unknown, which is excellent. So I'm just going to substitute in my results for P sine alpha and P cos alpha. So this one divided by this one to give me tan alpha, which is 0.2219, etc. So again, I'm putting in those dots so that the examiner knows I am actually using the whole answer. I'll just leave it on my answer screen. So alpha is 12.512. Again, showing that I'm going to use all of my answers, all of my digits later. And that is 12.5 degrees to 3 significant figures. Now that I've got alpha, obviously I can find P. Doesn't matter which of these two, so whether it's sine or cosine, doesn't matter which of these I substitute into. This one is just slightly easier to retype into your calculator. So I'm going to use P cos alpha equals 21 over 2. So P cos of my answer, again, ... I'm showing the examiner I'm using all of the digits, and that's equal to 21 over 2. So 21 over 2 divided by cos of 12.512, blah, blah, blah. So therefore P is equal to 10.8 newtons to 3 significant figures.